Hello and welcome to group number 205's number type sorting algorithm screencast. The members of group 205 are Daniel Asofai, Adam Dempsey, Armin Hanley, Eamon Elgendi and Jordan Cagney. The problem that we were presented with in our class was a number type sorting algorithm in which we have to list a list of positive integers, all of which are greater than or equal to 2. We should have to arrange these numbers into 3 groups within the list, with even numbers coming first, followed by composite odd numbers, and prime numbers sitting in the tail of the list. Our plan was to develop an algorithm to do this, which does not use an auxiliary list. To work effectively as a team, you have to devise a work plan. A good habit is often to devise a plan of how you'll go about doing it and necessary steps that you'll need to carry out. For us, these steps included working as a team and sharing each task equally, assigning group roles to make it easier to work as a group, stick to proven systematic problem solving steps that we've been taught in class. We kept a log of any problems that we'd encounter and how these problems were overcome and how we can overcome them better next time. And we were strict with our timekeeping, focused on thinking about the problem creatively and effectively in order to come up with the best solution. Within our plan, we thought it was important that we came up with a few different solutions so that we could effectively compare each solution and come up with the best possible one. To devise our solutions, we made sure that we were creative and thought outside the box. We compared each solution for its pros and its cons and used programs that we had written within Python to test them. And we evaluated each solution 100% to make sure that we'd made the best decision. All the information that we had on the problem and all the information that we came up with during our studies helped us come up with better solutions. We used problem-solving steps such as transfer to implement the problem and come up with the best solution we possibly could. We talked about who this problem would affect and how that affects how we would come up with a solution, and what uses it had in real life, such as cryptography or coming up with codes. The systematic problem-solving steps that we decided to focus on were to define the problem, to brainstorm our possible solutions, to choose the best possible solution that we've come up with, implement this solution against the others to make sure that it's the best, and then review it to see what we could do better next time, and to make sure that we've made the best choice. At the end, we came up with 2 solutions, one clearly outweighing the other. In our first solution we came up with, we realized that the solution worked, and it was easy to implement in programs such as Python, but it wasn't as easy to understand, and it wasn't as quick and easy as our second solution. So we decided to go with our second solution and run an implementation through Python to test our program. In order to test our chosen solution, we decided to write a Python program to run our solution and check if it was correct. We started writing a function called isPrime that we'll use later to test whether a number was prime or not, which is obviously very important for our algorithm. Our next block of code was to move all of the odd numbers, test each element of the list and move all the odd numbers from their current position to the end. With this happening, we would have a list of numbers that would start with a mixture of even numbers and prime numbers and end with only composite odd numbers. The next part of our algorithm we had to implement was to move all of the prime numbers, much like the way we move the odd numbers, from their current position to the end of the list. If our code was correct, this would mean that the start of the list comprised of all the even numbers, followed by the composite odd numbers, and ending with the prime numbers, which is exactly what we needed for our algorithm. To test this algorithm and to test our Python code, all we had to do was to add a random list of numbers comprised of even numbers, odd numbers, and prime numbers, and run that against our code that we'd written in Python. to see if it was correct. As we can see here, when we import our code into a Python REPL, using a random list of numbers containing even, odd, and prime numbers, we will return a list comprised of even numbers at the beginning, followed by composite odd numbers, and ending with the prime numbers, which we have here. Even numbers, composite odd numbers, and prime numbers. In order to better learn how we'd done as a group and how our systematic problem solving steps had led us to the best possible solution, we decided to run a survey among our friends and family and to get some yes/no answers from them after watching our presentation. So the questions we decided to ask were: was the screencast informative enough? Did you find it easy to follow the steps to our solution? Are you aware of any uses of prime numbers? And would you be able to use our systematic problem solving steps to solve any problem? The results we got back were mostly positive, apart from are you aware of any uses of prime numbers, which people seem to not really be. Although this is bad in terms of how we affected them and how our code could be used in everyday life, it's good that they've learned from our problem solving steps and know that they could implement them themselves. As a review of our actions and our project, we decided to ask ourselves as a group some questions and see how we thought we did. So the first question we asked ourselves is, did we solve the problem as a team? Which I think we proved we did. We all took an equal amount of work. We all put our own possible solutions and our own input using Trello boards and group meetings, etc. And we solved the problem effectively as we possibly could. Did we test different solutions and ensure that we'd chosen the most effective one? We did. We each brought our own solution to the table, narrowed it down to 2 possible solutions, and then tested these 2 solutions against each other to see which one was best. And I believe the one that we came up with was the most effective solutions we could have. What did we learn? We learned to work as a team. We learned how to use things like Trello and screencasts to effectively present our work. And most importantly, we learned a lot about the systematic problem solving steps that we need to use when we encounter any problem, and how this can be applied to any problem that we may come across in any line of work. So thank you for watching our screencast. Hope that you have been informed on the systematic problem solving steps that we've used to solve the problem that we presented, the number type sorting algorithm. Thank you.